Hello everyone. So today we are going to discuss about this LeetCode problem, which is magic squares in grid. So what this problem says that we are given a grid of numbers and need to count how many 3 cross 3 subgrids are there, which are called the magic squares. A magic square is a 3 cross 3 grid filled with distinct number from 1 to 9, where every row, column and both the diagonal sum is equal to same. Let's say 15, because sum of 1 to 9 will always turn out to be 15. So instead of natively checking all possible 3 cross 3 subgrids by brute force, we can use this mathematical property of 3 cross 3 magic squares to quickly eliminate impossible candidates. So what we need to check is the necessary condition in a smart order. First, check if the center is 5, because in any 3 cross 3 magic grid with a square number 1 to 9, the center must be 5. Then, if check whether all the corners are even. These are the quick checks that eliminate most of the subgrids immediately. We need to verify if 3 cross 3 subgrid is a magic square. Instead of checking all the conditions at once, we check the easiest one first. The center must be 5, the corners must be even, which eliminates most of the subgrids quickly. For verifying all numbers 1 to 9 are distinct, we use a simple array instead of a hash set for better performance. Look, there's no need of fancy data structures here. Since numbers in the grid can only be up to 15, we can use a boolean array of size 16 to track which number we have seen. For sums, we have checked diagonals first since they are easy, then rows and then columns. So let's take carry on with our example only. Uh, let's take an analysis of our first grid. Okay, this is our first grid, and what we need to see that first we check that whether the center is 5. Yeah, center is 5. Then we say all our corners are 4, 8, 2 and 6. Yes, all our corners are even. Then what we see whether all the numbers from 1 to 9 are distance. Yeah, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Yes, all the numbers from 1 to 9 are distance. Then we see first row, s- some are equal, that is 4 plus 3 plus 8 is equals to 15. Yeah, correct. 9 plus 5 plus 1 is equals to 15. Yeah, correct. 2 plus 7 plus 6 is equals to 15. Yes, all rows sums are equal. Then we check whether all column sums are equal or not. So let's make a space to check that. So what is the 4 plus 9 plus 2, which makes it 15? Yeah. Then second column 3 plus 5 plus 7, which is up to 15. Yes. 8 plus 1 plus 6, which also makes it to 15. Yeah. So all the columns are also same. Lastly, we check our diagonals, which is 4 plus 5 plus 6, which is equals to 15, and 2 plus 5 plus 8, which is also 15. So we took around a dive into what did we checked first and how did we check. First we checked whether our center is 5. Yes. Then we checked whether all the corners are even. Yes. Then we checked whether all the numbers are distant from 1 to 9. Yes. Then what we checked whether all the rows sum is equal. Yes. Then we check whether all the column sum are equal. Yes. And then we check our diagonal and anti-diagonal sum is also equal to 15. Let's take the second subarray now. Um, let's duplicate it and bring it down. Let's remove this extra. Yeah. So now let's check where our second subgrid. So let's what we have to check firstly that our center is 5 or not. See, our first check has only eliminated that the center is not 5, it is 1. Therefore, it gets eliminated quickly. So this is a very simple approach that we can find. Okay. Now we take an example, another example. Suppose we have a grid of 3 by 3. Another grid is given which has a center 5. All the columns are even and all our centers are same. Is it a magic grid? No. Why? Because yes, our center is 5 checked, all our corners are odd checked, but we do not see the distant number. That is, it has two fives. Therefore, it is eliminated in third x step. So when we check like this step by step, it will make us very easy to eliminate most of the. Now let's code it. How we'll write it in a code? Let's check that quickly. So first, what we have to check? We have to check the grid size. So suppose we take a variable int rows equal to grid of length. Then we take columns and column equal to grid of 0 of length, and if row is less than 3 or column is less than 3, we can directly return 0 because then our magic grid is not possible, because our magic grid is only possible when it is 3 cross 3. So that will be our first check. What will be our second check is that we have to iterate through all the possible 3 cross 3 subgrids. We need to check every possible position of 3 cross 3 square. If the grid has rows and columns of 3 cross 3, we can start with I, and similarly it can start from J, and from the starting position we can check if it's a magic square or not. Suppose let's take a iterator named as count 0. It is used to it we will use this counter to initialize how many numbers of total magic squares are there in our grid, so it will keep a track of our actual answer. So let's take for int I equal to 0, I less than equal to rows minus 3, and I plus plus. Why we are doing minus 3? Because we have to take 3 cross 3 matrix, and for that we need to skip the last 3 rows because it is not possible from it to start from the index 2, and it when it will iterate. Suppose we have a 4 cross 3, if it is here, when we do plus 3 it will eliminate here, so we don't have any indexes over here. That's why we are taking it as minus 3. Okay, so it's very understandable. I think you are following up with me. If you didn't follow anything, just go back, rewatch this video as many times as you see, and clear your doubts in the comment section as well. So what our inner loop will be, it will go from 0 to column minus 3. Just we are iterating through each start index to find whether it is a magic square or not. So we'll use another function, if magic square. we'll send our grid, we'll send our ith and jth positions. And if it is a magic square, we will increase our counter. And at last, we'll return our count value. So this is our basically the whole structure. And now we'll see what will go inside our if magic square function. So what we have learned uh, in that if magic square will contain six checks. First check was if center is 5 or not. So we'll basically check if grid row plus 1 and column plus 1 is not equal to 5, then we'll return false because it can't be our magic square. So because in we have checked that the for any 3 cross 3 magic square the center must be 5. So that will basically eliminate our any grid which is not equal to 5. Okay. So what was the second check? The second check was checking if all the corners are even. So let's write the condition for that. If grid row column mod 2 is not equal to 0 or grid row column plus 2 mod 2 not equal to 0, that is top left corner is even or not, top right corner is even or not. Now let's check whether grid row plus 2 and column mod 2 is even or not. And lastly, we'll check our bottom right corner, that is grid row plus 2 and column plus 2 mod 2 is even or not. If any one of them is not even, then we'll simply return false. If any one of the corner is not even, our second condition will also fail. And then we can directly say it is not 3 cross 3 magic square. What was the third condition? We can check in third condition that if the diagonal sum is equal or not. So, so let's take the diagonal sum, which is grid of row and column plus grid of row plus 1, column plus 1 plus grid of row plus 2 and column plus 2 not equal to 15. We have checked that sum will always be 15. Okay, so if it is not 15, we'll simply return false. This is for our main diagonal. Now check we can check for our anti-diagonal as well, which is grid of row column plus 2 plus grid of row plus 1 and column plus 1 plus grid of row plus 2 and column not equal to 15. If this sum is not equal to 15, then also we can simply return false and say it is not our 3 cross 3 matrix magic grid. Okay, so what was our next check was if all the elements are distant or not. So for that we can take a boolean array named check and is equals to new boolean of 16, and we'll take for int I equal to row, I less than equal to row plus 3 I plus plus. It will loop through all the three rows of the subgrid. Then we'll take our sub loop, which is starting from j equal to column, go till column plus 3 and j plus plus. This loop will go through all three columns of the subgrid. Then we'll simply take our variable, suppose num equal to grid of I comma j, and if num of is less than 1 or greater than 1, or check of num, then we can simply say it is not distant or does not in the limit of 1 to 9, and we'll simply return false. And scene of num will always be true marked when we have checked our array. So this is our fourth check, which we'll see whether our all the numbers of the subgrid are distant or not. So let's check our fifth checker, which is checking the sum of rows. So it is for int I equal to 0, I is less than 3, I plus plus will go till for uh, we just need to check the array. So we'll see if grid of mm, what's happening with my app, and if grid of, I think it's battery is low. Okay, let me quickly write it. If undo, if grid of mm, row plus I row plus I and column plus grid of, basically what we are doing here, we are checking whether our sum of all the rows is same or not, which is equals to 15. If it will be 15, and instead of taking two loops, we are checking in one loop only. And if it is not equal to 15, we'll simply return false. Okay. So what we have done till now, we have checked whether our center is 5, whether our corners are even, whether our diagonal sums equal to 15, and all number 1 to 9 is distant. And here we have also checked whether our all the columns are equal to, are all the rows equal to 15 or not. So our last check would be to check whether all the columns are equal to 15 or not. So simply what we'll do, we'll take a loop from 0 to less than 3 to check all the three columns, and we'll not take two loops. Instead, we'll take if grid of row column plus j plus grid of row plus 1 column plus j plus grid of row plus 2 column plus j. If it is not equal to 15, we'll simply return false and say it is not our 3 cross 3 magic grid. If all it is true, at last we'll return our true. Okay, so this was a very simple approach which we have done. I'll give you all the code in the description, and if you have any doubts, just put it in comments. I'll try to reply each of one of you. And if you like this video, just give it a thumbs up and go ahead. Don't stop learning every day. Try to solve as many questions as you can and be better each day. Bye bye.